Okay, good morning and welcome to DSC1630, Chapter 3, Section 2 of Introductory Financial Mathematics. My name is Adil Immelman and I'm the lecturer for the video series. Now today we're going to look at odd periods. Now firstly, what is an odd period? Now sometimes you don't invest your money on the 1st of April, for instance, and you take it out of the bank on the 30th of a month. So if we can say a full month or a full period or compounding period, but sometimes you just invest your money on a specific day. Let's say the 12th of April or the 6th of January. Right. Now what happens if we're working with compound interest and your interest period or your investment period isn't a full compounding period? Now that, when we've got something like that, we call it an odd period. So it's not a full compounding period, but smaller. Now there's different ways that we deal with it. The first is, for that odd period, we use simple interest, which we had in Chapter 2. So for the odd periods, we use simple interest, and then for the full periods, meaning let's say it was compounded monthly, our interest rate, we use our normal compound interest for those full periods. So that's the one method. The second method is fractional compounding. We'll get to fractional compounding, but basically what it is, it's normal compound interest that you're using, but when you get to the time period, you take your odd periods and you express it, as well as your full periods, but you express it as a fraction of a year and to use as your T component in your formula. But we'll get to that when we get to an example. Now, with odd periods, it's very, very important to draw your timeline. As we all know, the timeline is so helpful with all our calculations, but especially when we get to odd periods. Now, how do I know when I'm working with odd periods? Now, firstly, when you draw your timeline, you will see that firstly, or secondly, the wording of your problem. There will always be compound interest, and then either it will give you the method of using odd periods, simple interest for odd periods and compound interest for full periods, or the word fractional compounding will be there. But very important, there will be a compound interest. How do I calculate? Using my calculator, straightforward. You can either use the financial mode or the normal mode, or with a combination where we've got simple interest and compound interest, you will then use a combination of the financial and the normal mode. Now let's look at an example. And let's go back to our board again and read through the question quickly. A typical question. On the 5th of April, Sam invested $75,000 in an account paying 8.37% interest per year compounded monthly. Interest is credited on the first day every month. Sam wants to move into his new shop on the 21st of November of the same year. Determine the amount of money that Sam will have available on the 21st of November of the same year if simple interest is used for odd period calculations and compound interest for full period. So if we read through that, what actually gives it away, our ID word is in the last sentence. When simple, you've got the odd period there, and it tells you use the method of simple interest is used for odd periods and compound interest for full periods. That's very important to firstly make sure of the ID method of our odd periods. So the word odd period plus the method is in the question itself. Now again, we've got a cake recipe that I normally, as you all know, I like the cake recipes. And how do we approach this question? Now, very important, as we did already, we read through the question and we identify it by those specific identifying words. And in this case, it was the odd period calculation, and the method was given to us as well. Now, the first thing then is we draw our timeline. Now, if you can remember, let's go to our board. We need to draw our timeline. Okay. Now, the first thing I do with the timeline, always, I start with the begin and the end date that was given to me. So if I go back, let's leave the question for now on the screen. Let's just, sorry guys, let's just get that. There we go. Okay. It starts on the 5th of April. So we'll write down our 5th of April. So that's the first thing we do. And then our last date, Sam wants to move into a new shop on the 21st of November. So that's the first step that we do. We enter our begin and our end date. Then our second step is we fill in our interest dates in between the 5th of April and the 21st of November. Now that will give you the indication of where the odd periods are. So if we look at that, it says interest is credited on the first day of every month in that specific year. So if it's the 5th of April, the first one after the 5th of April will be the 1st of May. Right? Then the 1st of June, 1st of July, 1st of August, 1st of September, 1st of October, and the 1st of November, and then the 21st of November. So our interest dates we fold in, and that is our second step. So our first step is first date and the end date. Secondly, in between all our interest dates. Right. Next is, now we're going back and we identify our odd periods. Now you can see from the 5th of April to the 1st of May isn't a full period. Why? Because it gives us that it's the interest rate, remember JM, is 8.37% per year, but it's compounded monthly, so your M is 12. So your compounding periods is monthly. So from the 5th of April to the 1st of May is then what we call an odd period. It's not a full month. Right. Now what about this over here? From May to June, June to July, those ones up till November, that is now full periods. So this over here up till the 1st of November, 1st of November is full periods, and then from the 1st of November till the 21st of November is then again odd periods. Happy with that? Right, so we've got odd periods, full, and odd periods. Now the third one, after we've identified it, our steps, we would now count the days or determine how big is this odd period. Now firstly, how do we determine, in this case is from the 5th of April to the 1st of May, so now we're working with days. So we count the days from the 5th of April till the 1st of May, and can you remember how do we count the number of days? Either your fingers, or what is easier is your date table. Right, and remember in the exam you will be receiving the date table as well. So the 1st of May, if you look at the date table, is the date 121, and April is 95. So the difference between these two, 121 minus 25, gives us that our first of odd periods is 26 days. Right. Now what about the full periods? Now be very careful when you calculate the full periods. Remember, I'm talking about full periods, not interest dates. If you count the interest dates, it's 1, 2, 3, 4, 5, 6, 7. And that's wrong because we're looking for the number of compounding periods. And if you look at the X's that I've drawn just now, a period is between two dates. So it's 1, 2, 3, 4, 5, 6. So in this instance, our value is 6. Right. 6 full periods. And then our odd period, again from the 1st of November till the 21st of November, the first is 305. Where did I get that? On my date table, and 325. Can you remember the rows? Or if you go down in a column, you will have the different dates, and in the row, that date in the column, for that specific month that you're going to work with. So that gives us the odd period here is then 20 days. Right. Now what am I looking for? I know the value here is, what was it again, 75, if I can remember correctly. Yes. We started off with 75,000 here, and I want to know what the value here is going to be. So this is my future value, and this is my present value. Right. Now, they said we must use simple interest for our odd periods, and for the full periods, we must use compound interest. So what will happen is I will take the 75,000 and use simple interest for 26 days, and I will get an answer on the 1st of May. After I've calculated that, I will then use this value as the present value for the next part of our interest calculation up to here, which is compound interest. So it's my simple interest. The answer of my simple interest, I use compounding it up to here. Then when I have this answer here, I then will use simple interest for that period there. One thing you must remember, that here you start off with a 75,000 as your present value, and you calculate a future value. But when you begin with the next one, this answer that you got becomes a present value for the next calculation. The same here, your future value for the second calculation becomes the present value for the third. Now there's two ways that you can do it. You can do it in 3 separate steps if you want to, but just be careful. If you get to an answer, don't round it off. Otherwise, at the end of the period, you're going to have a different answer in the decimal. So what I normally do is work with that answer, carry on with it, and the next one, without rounding it off. Only round off the end answer. The other way is write all 3 of these in one question or one expression and calculate it once, one after the other. Right, so let's go back then. Firstly, we set simple interest for the first part. So our first step will then be, we use S equals P 1 plus RT, right? What is our present value? Is 75,000. 1 plus our interest date is 0,0837, right? And it's monthly. Do I use it? No, because it's simple interest, right? And your time period is 26. Do I just use 26? No, because 26 is days, right? And can you remember, our interest rate and our time period always goes together. So if our interest rate is per year, then our 26 must also be a fraction of a year, and it's 26 days. So how many days in a year? 365. Right. So if I take the 75, I use compound interest, simple interest for that period. I will get an answer of 75447,16438, and I just put dots to say it actually is on, but I'm not rounding it off. So this value here This value here is the value then here. Right. Now what are we going to do next is we're going to take now this value that we've got in red that we've just calculated, and that becomes the present value for our next calculation up to there. But now we must use compound interest. So we write down step 2. Compound interest, the formula P1 plus, can you remember, Jm over m to the power of T times m. Right, what is our present value? Be careful, it's not 75, it's now the present value of the red, and that is the value 75447. So we would enter 75447, comma 16438. Can you see how using the whole number? 1 plus our interest rate 0,0837, and remember guys, I must divide by the number of compounding periods, and that is 12. Why? Because we're working with compound interest now. The previous one was simple interest. We don't divide the interest rate. To the power of T times M. What is T? T in our instance we said was 6, right? But it was 6 months. So if we need years, we need to write it as years, 6 over 12. Can you remember T always years? Times M, and M is 12. Right, that is your bracket. And if you work that out, either with your financial mode, right, or you can use normal mode on your calculator, we do get an answer of 78660, 201, and so forth. Okay. Now again, what do we know? That was the answer we got over here. But that now becomes the present value of our last calculation. Right. So we know this 778 becomes the present value for our last calculation, the green. Okay, so let's go to a new clean slate. What do I use? Do I use compound interest, just go back, or simple interest? I'm using simple interest for odd periods. So I'm going back to my simple interest formula, which is S equals P1 plus RT, right? What is the present value now? Is that 78660, 20122, whatever. 1 plus your interest rate 0,0837 times your T. Now if you go back to T, what is our T here? It's 20 days. Can I just use 20 days? No, I have to change it to years. So it's 20 divided by 365. Why 365? Because there's 365 days in a year. You work with 365 unless I tell you to use another number. Right, and if you work that out, that will give you 79020,96. So if you calculate that, that is the answer then that you will have. Let's just go back to our previous one. Over here, it's 79020,96. And that is our answer. Right. So, to recap, what do we do with odd periods? We try and get our begin and our end dates. Secondly, fill in your interest. That's between those, the interest dates between the beginning and the end date. Right. Determine the odd periods. Then you count the odd and the full periods, the number of days and the number of full compounding period. And then you start your calculation. First use simple interest, then compound interest, and then simple interest again, right? And remember, the answer that you're getting from the one becomes the next one's present value, the next calculation step. Right. Was the one method by every time calculating the next question, the next answer, and then using it in the next one. The second method is we can just write it all. Let's go back to our black one quickly. What we actually did, if you go back, right, we use simple interest, right? Then we use compound interest, and lastly, we use simple interest again, right? So we can actually write that total in one sentence and saying it's P times 1 plus RT, and then we multiplied whatever answer we had for this, we multiplied by our JM over M TM, and then the answer of this whole thing we then multiplied by 1 plus RT again to get to the answer. So you can actually enter that whole thing into your calculator to get to an answer. So you would write 75,000 1 plus 0,08, was it 37, times, it was 26 days, and then 1 plus 0,0837 divided by 12 to the power of 6 over 12 times 12, which just gives you 6 as well. And that you would multiply then with your 0,0837 times 20 over 365. Right. So, guys, you can write it out in one step almost and work it from left to right. Otherwise, you can use the 3 steps that we did previously. Whatever method is the easiest for you, just remember, don't round off your answer if you're carrying it on to the next step. Right, so let's go back to our presentation, our PowerPoint, and just to recap, okay, we read through the question, we identified it, we filled in red our 5th of April and 21st of November, as well as the interest dates. We determined the full and the odd periods. We determined the number of days of the odd periods using our day table, as well as the number of full compounding periods. And again, guys, be careful. Don't count the interest dates. A period is between interest dates, so that gives you 6. There we've got our timeline, and there's the method. The first method is using the 3 steps that I've spoken about, and then lastly, method 2, writing it out as one big calculation and get to your answer. Right, now we're going to look at the same question, but using fractional compounding. Now, as I said, what is fractional compounding in the beginning? Fractional compounding is normal compounding. So if I would write normal compounding is S equals P 1 plus JM over M TM. Right. So it's normal compounding. We know what is P, we know what is JM, M, but the most important is T. And that's where we say fractional compounding, because we write our terms, our odd periods as well as our full term, as a fraction of a year. So if we go back to to our picture over here, we had the 26 days, right? We had the full period of 6 months, and here we had the 20 days, right? So that we now need to put as a fraction. Now, firstly, the 26 days is how many, or a fraction of a year becomes 26 over 365, right? The 6 months becomes 6 over 12, and the odd periods, again, the last 20 days becomes 20 over 365. 20 over 365, that's correct, yes. So if we look at that, our T here, which is very important then, our T is the 26 over the 365 plus our full period, 6 over 12, plus, can you see I'm using 12 here? Why? Because it's compounded monthly. Why am I using 365? Because it's daily, plus 20 over 365. Right. And that is my T value. So all that differs from normal compound interest is that your T is expressed as a fraction. Right. So each period you're actually expressing as a period, a fraction of a year. Right, so if we go back to our problem, it will be 75,000, 1 plus our interest rate, 0.837, divided by our 12. Our T will be that T there, and then M will be times 12. Why this 12 and that 12? Remember our formula T times M. Right. Again, just something quickly to go back to the question. What actually gives us the method we've got to use, and if it's odd periods, the word fractional compounding. So when you see the ID word fractional compounding, you know we're working with fractional compounding as such. So there it is, use compounding formula, but the time period calculated as a full period plus the odd period expressed as a fraction of the year. So in this case, T is then 26 over 365, 6 over 12, 20 over 365. Now let's say we didn't have question 1 where we actually drew our timeline. Then you first got to draw your timeline from the information in the question and get those, classify those odd periods and full periods before you go over to the fractional compounding formula. So always, remember in the beginning I said, remember to draw your timeline. And your begin and your end date plus your interest dates, and then you determine the odd and the full periods. And that will then give you your T value that you use in your formula. Now there I've worked it out, and you can see the answer is 79,02029. But if we go back to our previous question, method 2, it was 79,096, can you see? And this method gives us 79,002.29. Why? Right. And that's why I say fractional compounding, you must always be very careful if the bank uses fractional compounding, because it differs. When you have 75,000, it's not that big amount. But if you have millions, it will give you a different answer in the way they calculate those odd periods. So make sure you know how they calculate it to know what amount you will have at the end of the day. You could have used another way of fractional compounding that people use is they physically count the days from the beginning to the end, and that they use as a fraction of a year and then multiply by 12. That again will give you another answer. But if for our case, we're using this method that I'm giving you on the board for fractional compounding. You express each the odd as well as the full period as, so you don't count the specific days from the beginning to the end by using our method. Otherwise, you will have a different answer. In this instance, it was just in the decimals, but when you get to big amounts, it gets to your rand values as well. Right, I've just giving you that slide on the calculator. Even though with fractional compounding, you just need to use your normal compound interest formula. All that differs is your N value is quite a big value. You first got to work that out or calculate that before you press your N button for the power. Right, so your N, you first work out on separately, and then you enter it as your N. The rest is the same as normal compound interest. Your present value, your periods per year, and lastly, you press your future value to get to an answer. Right, that concludes then odd period calculations. Guys, again, as I always say, remember practice makes perfect. Go back to your book, your guide, do all the examples, all the exercises in your guide, as well under additional resources on my UNISA, you will find some extra exercises plus solutions. Diane, pauwtje. Hierdie een.